this I'm going to call the binary entropy function. Because it calculates the entropy of a binary source where one of the letters has probability p. Okay, so we have that h of y given x is equal to this, which is equal to little h of pe. Let me write that over here. So h of y, well, in order to get h of y, I need p of y. P of y is equal to the sum over x of p of y given x dx. So this is equal to okay, there's three possibilities here. So for y equals 1, what I have here is the sum over 0 and 1 of this. Sorry, let's start with y equals 0. I have p of 0 given x is 0 times probability x is 0 plus probability y is 0 given x is 1, probability x is 1. Let me make that explicit. Probability of getting a 0 out given a 1 goes in is 0. That term is 0. And I have this, which is 1 minus PE, probability x equals 0. If y is 1, I have probability y is 1 given x is 0, probability x is 0, plus probability y is 1 given x is 1 times probability x is 1. Now this is 0, probability of getting a 1 out given that a 0 goes in is 0. And this is 1 minus PE times probability x equals 1. And for y as e, I have probability of getting an e out given a 0 in times probability x equals 0, plus the probability of getting an e out given x equals 1 times probability x equals 1. But in both cases, these are the same. They're both PE. So this is equal to PE. So let me rewrite that. For y equals 0, I have 1 minus PE times probability x equals 0. For y equals 1, I have 1 minus PE times the probability x equals 1. And for y equals e, I have PE. Now, let's calculate h of y. H of y is equal to, okay, for y is 0, I have 1 minus PE, probability x equals 0, log 1 over 1 minus PE, probability x equals 0, plus 1 minus PE, probability x equals 1, log 1 over 1 minus PE, px equals 1, plus PE, log 1 over PE.
What was the value you wrote here? Sorry.
Which value?
The curly brace at the bottom.
probability of y. Okay, so we can simplify. Let's take out 1 minus PE. So I have P x equals 0 log 1 over 1 minus PE, P x equals 0 plus P x equals 1 log 1 over 1 minus PE, P x equals 1 plus that. P log 1 over P. One more step of simplification, I can take out a log 1 minus PE from both of these terms. So I get 1 minus PE, P x equals 0, log 1 over 1 minus PE, plus, I can take the same term out from this side, P x equals 1, log 1 over 1 minus PE, and then the remaining term, plus P x equals 0, log 1 over P x equals 0, plus P x equals 1, log 1 over P x equals 1. It will get simpler. And then plus this trailing term, PE log 1 over PE. So what I end up with, this is log 1 minus PE, this is log 1 minus PE. So I have x0 plus x1 times log 1 minus PE. And that just becomes log 1 minus PE. So I have 1 minus PE. If I collect these two terms, I have log 1 over 1 minus PE. Now, what are these two terms? Px equals 0, log 1 over Px equals 0, Px equals 1, log 1 over Px equals 1.
Hx.
It's h of x. Plus PE log 1 over PE. Finally, I have, expanding this, 1 minus PE, h of x, plus 1 minus PE, log 1 over PE, plus PE, log 1 over PE.
Isn't the second term the denominator? 1 minus p.
1 minus PE. What's that?
H of. Oh no.
It's this little h of PE. So, mutual information is equal to 1 minus PE, h of x, plus h of PE, minus, that's h of y, minus h of y given x, which is h of PE. That cancels with that, and we get 1 minus PE, h of x. So, what's capacity? So x, h of x is over a binary input, so what's the maximum possible value of h of x? 1. So capacity is 1 minus PE, and this occurs with the equiprobability.